Okay, let's start. Physical properties. So if we're going to see physical properties, so first of all, we are going to start metals and not melting point and boiling point. Melting point. We will see melting points and boiling points. So in class 11th, you already studied about how we are going to compare melting point and boiling point. So the first question you can see, wait a minute. Melting point and boiling point. So I'm going to give some questions to you and compare its CH3, CH2, 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 Br, CH3, CH2, CH, CH3, Br. Now CH3, C, CH3, CH3, and then Br. You can see if we are going to see the boiling point order. So you need to see boiling point is directly proportional to surface area of the molecule, and boiling point is also directly proportional to the molecular weight. Now you can see all the compounds in this have same molecular weight. So we will compare this boiling point on the basis of surface area. The compound which has more surface area will have more boiling point. So can you arrange this? 1 bromobutane, 2 bromobutane, and 2 bromo 2 methyl propane. Can you arrange this in increasing boiling point? Please do this.
Sir, in increasing order or decreasing?
Whatever is suitable for you, the most and the least having boiling point, let me know.
The most is the last one, 3 bromo.
Most the compound which has most boiling point is the last one, 3rd.
Yes.
Sneha, what about you? Hamza, see, its surface area decreases because there is more branch, or you can also write boiling point inversely proportional to branches. The compound which has more branches will have lesser boiling point. So this has more branches, that means it will have least boiling point. So the boiling point order will be like this. Got it?
Yes, sir.
Very good. Please write. Please name this compound first. You pick name, and then arrange this in increasing or decreasing order of boiling point as well as melting point. First, you are going to write its order in boiling point and then melting.
So the first one is 1,2-chlorocyclohexane. The
Is
second
it
one is
cyclohexane? Nafisa, is it cyclohexane?
isn't it? Yes, sir, the shape.
What it is then? It's benzene. So the name will be 1,2 dichlorobenzene, 1,3 dichlorobenzene, 1,4 dichlorobenzene. Now see, if you are going for boiling point is depends upon surface area as well as molecular weight. All will have the same molecular weight because molecular formula are same. So according to this, I'm going to take this A, this B, and this is C. So the one with the highest boiling point will be this ortho, then para, then para, C, then C, and then B. Melting point basically depends upon packing. Melting points depend upon packing. So I'm going to write here A, then C, then B. And the boiling point difference between this meta and para is very less. And if you are going to see melting point, so the molecules of this fits very good. That means they packed very tightly. That's why its melting point is highest. Then this ortho, and then the lowest melting point will have the this. So please write it, and it's very important.
Yes, sir.
Done.
Yes, sir.
Very good. Sneha and Hamza. Very good. So now arrange each set of compounds in order of increasing boiling points. The first one is bromomethane, then bromoform. You have to write the structure of this compound, then you can easily decide. Chloromethane, and then dibromomethane. Now the second is 1-chloropropane, isopropyl chloride. 1-chloro butane. Let me know if you have any query about this question. Nafisa, are you done with the first one?
Yes, sir.
Yes or no?
Yes, sir.
Okay. Which one will have the highest boiling point?
Bromoform.
Bromoform. And then the lowest? Lowest?
Dibromomethane.
Dibromomethane. See, first of all, if you are going to compare boiling point directly proportional to surface area, boiling point is also directly proportional to molecular weight. Molecular weight. So if you are going to see bromomethane, that means CH3Br. Bromoform, that means CHBr3. 3Br is there. Whether it is bromoform, chloroform, that means CHCl3. Chloromethane, that means CH3Cl. And dibromomethane, that means CH2Br2. So can you tell me which one will have the highest molecular weight? This one. So it will be the number one. That means the most basically highest boiling point. Yes or no? Nafisa, this is correct.
Yes, sir.
Now you can see this will have the second number. You can see second rank for molecular weight. So it will be then chloromethane and bromomethane. So it will be third position and the fourth position will be like this. Yes or no? Hamza, Sneha,
Yes, sir.
the one with lowest molecular weight will have the lowest boiling point because all will have the same structure. Now do this. Fatima, why you joined late? And you always live in between the classes. You always leave this meeting in between the classes.
Sir, the biggest one is chlorobutane. The
No,
one with
wait a minute.
higher boiling.
Highest boiling point, which one will have the highest boiling point? This?
Yes.
Then?
And then isopropyl chloride
No,
and
no, no, no,
propane.
no. See, chloropropane is like CS3, CS2, CS2, Cl. And
Yes, sir.
isopropyl chloride is like CS3CH, CS3Cl. So it's
Okay.
both will have the same molecular weight, but this one has lesser surface areas than this. Yes or no?
Yes, sir.
So one this and second is this and the third in decreasing order. Okay.
Yes, sir. Okay.
Please write. Please let me know when you are done with this.
Yes, sir. Finish.
Finished. Very good. Can I change this slide? Okay. Now see, we are going to study about chemical reactions. Chemical reactions. So chemical reaction, there will be three types of chemical reaction which we have to study here. So the reaction, chemical reaction is like chemical properties of, we are going to study chemical properties of haloalkane as well as haloarenes. So here we are going to take first reaction of haloalkanes. Reactions of haloalkanes. So basically there are three types of chemical reactions of haloalkanes. So the reaction of haloalkanes may be divided into the following categories. The first one is nucleophilic substitution. The second one is elimination reactions. And then reaction with metals. So these three types of reaction we are going to study here. Please write.
Yes, sir, finish.
Everyone done with this? Sneha, Fatima. Okay. So let's start with the first one. Nucleophilic substitution reaction. Nucleophilic substitution reaction. You can see this is nucleophilic substitution reaction in which we have to take care of two terms, nucleophile, and there will be electrophile also. And nucleophile is the one which loves nucleus, that means positive charge. And any compound or any species which have positive charge is basically electron deficient. That compound on which positive charge will be there, that means that compound is electron poor or electron deficient. And nucleophile is basically nucleus lover. That means basically this nucleophile is electron rich compound. And this nucleophile can be of two types. Either it will be neutral or it will have negative charge. And the compound which is neutral with lone pair, not like this BF3. Can anyone tell me, is it BF3 is neutral? Is it nucleophile or electrophile? You have studied this in class 11th. Can anyone tell me which type of species it is? Electrophile and nucleophile. Nafisa?
Nucleophile.
Nucleophile, not nucleophile. See, BF3, that means it is making 3 bonds. How many electrons does boron have? Can you tell me? Anyone? How many electrons boron have? CH4, how many electrons does carbon have in the outermost shell? Nafisa? Do you know, or I should explain? No, you were not audible. See, CH4, that can you tell me how many electrons present in a bond? In one bond, how many electrons are there? In one bond, how many electrons are there? Sneha, Fatima, Hamza, two electrons in one bond. That means 4 bond. That means 8 electrons. And here boron making only 3 bonds. That means 6 electrons. To be a stable, there must be 8 electrons, and it is lesser than 8 electron. That means it is electron deficient. And if it is electron deficient, that means it is an electrophile. Got it, Nafisa?
Yes, sir.
Please write it and let me know whether OH minus, H2O, CH4, CH3 plus, NH3, which one is nucleophile and which one is electrophile.
Sir, OH, H2O, CH4 is nucleophile and 4
This is
H3.
nucleophile, this is nucleophile. This is
Electrophile,
electrophile. What about this?
and that's electrophile.
This is nucleophile because it have, or you can say lone pair. This has lone pair.
Yes, sir.
That's why. And it's polar. This both have 8 electrons, not more than 8 electrons.
Yes, sir. Okay.
So that depends. This is not nucleophile either, not electrophile. So please write it and let me know. Everyone done with this?
No, sir. Yes, sir.
Very good. Now see, how does this reaction takes place? Nucleophilic substitution reaction. You can see there is substitution reaction. That means one will be replaced by other, and which one is nucleophile. A nucleophile will replace a nucleophile. So how this reactions takes place? Just suppose there is nucleophile, and you know this is haloalkane. Since we are studying chemical reaction of haloalkanes, so it will be like this. And you know X is more electronegative, so delta negative will be here and delta positive will be here. Now you can see that this positively charged will be attacked by this nucleophile, and this will leave this bond, broke this bond, and it will be like this nucleophile. It is replaced or substituted by nucleophile, and this will eliminated. So this is how this reaction will take place, or you can write haloalkane reacting with nucleophile will take this RNU X minus. Please write this.
Yes, sir.
Finished? Very good. Now see, there are basically two types of substitution reaction, nucleophilic substitution reaction. There are two types of nucleophilic substitution reaction. One is SN1 and the second one is SN2. So first of all, I'm going to write types of nucleophilic substitution reaction. Types of nucleophilic substitution reaction. The first one is substitution nucleophilic bimolecular. Substitution nucleophilic bimolecular, that is known as SN2 reaction. Please write this topic and let me know, then I will explain what it is SN2 reaction and what is SN1 reaction.
Yes, sir. Finish.
So first point about this, the reaction basically here, it's second order kinetics. We will study about the order of the reaction in chemical kinetics. So the reaction below, given below, follow second order kinetics. This is second order reaction, and also that is the rate depends of both reactants. That means basically there will be a nucleophile OH minus and this reactant. There are two reactant. You can see the rate depends on the both reactants and how reaction will take place. First of all, see, there will be delta negative, delta positive. This will be about to break. This will attack this. So there will be a transition state type like this carbon Cl, and here is hydrogen. Here it is also hydrogen. Here it is also hydrogen. And uh, during the during the process of breaking this bond CCl, there will be formation of bond between OH and C carbon. And this is how it takes place. Carbon, hydrogen, 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 and then OH. And then Cl minus will be omitted. Now again, I have to correct this. This is out of the plane. This is inside. Please write this. Then I'll explain again. Let me know when you are done with. Yes, I will explain again and I will write some point that will be more clear to you, Sneha. Done. Please write it carefully and let me know then. I'll explain again.
Yes, sir. Finish.
Sneha, are you done with this? Hamza, are you done with this? Very good. Now see, what I want to tell you is that see, this SN2 is single step reaction. First of all, see this single step reaction. No intermediate is formed. I'll explain again. No intermediate is formed. That means single step reaction. Again, back attack. Back attack. There will be always back attack. Order will be 1 degree, 2 degree, 3 degree. First of all, see what I have written, why I have written this. You can see if there is Cl and now you can see H, H, H and OH minus. So how does this CCl bond break? As we know that there will be delta negative charge, there will be delta positive charge. If this bond will be broken, chlorine will have negative charge. And if this want to go to this carbon, it is not possible because this negatively charged and this negatively charged will repel each other. So no reaction, yes or no? The reaction will take place or not? Please tell me. OH negative, whatever is the nucleophile here. Nucleophile is of two types. Either it will be anion, either it will be neutral, but in neutral state, that must have lone pair to donate. Nucleophile, that means the electron rich species. So basically, it will have electron that will have negatively charged, and this will repel each other. So it won't be possible for OH minus to attack carbon from this side. Yes or no? Please tell me. Nafisa, Hamza.
Yes, sir.
So that's why nucleophile in SN2 attack from back side. Now you can see hydrogen, 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 and also this will have negative, this will have delta positive. And if this bond will broken, OH minus from back side can easily attack carbon and form bond. Yes or no?
Yes, sir.
So it's very easy. You can see. So that's why I wrote here back attack, always back attack. Okay, and here you can see single step reaction. There will be no intermediate. You can see the reaction is in single step. The reaction is started from here and ends here. This is just the during of reaction. During the reaction, this will be like this. It's for explanation. So it is single step reaction, no intermediate form, and then order of reactivity is 1 degree, 2 degree, 3 degree. Why it is so? Now you can see, just let me know whatever I am asking. If there is CH3, just suppose, and H, and there is X, and OH minus is here. If there is CH3 here also, CH3 here also, and this is H and X, OH minus here. Now, this is CH3. This is also CH3. This is also CH3 and X. In SN2, there will be back attack always. Now tell me, in which compound OH minus can easily attack carbon? Can easily attack carbon? In which A, B, C, D? A, B, C, ND, in which OH minus can easily attack.
Sir, can you say again?
In which of the following compound A, B, C, OH minus can easily attack? OH minus can easily go to carbon and make bond. That means here, here, here. Can you do this, Nafisa, or not?
No, sir.
Okay, no problem. So you can see there is only one CH3 and H. Now every atom has its own electron. Yes or no? Every atom will have electron.
Yes.
So OH minus, if OH minus going here, you can see there is 3 CH3. There is C, H, H, H. Again, if you are going to see this and this, you can see 3 H is there. Again this. So basically, there will be steric hindrance, that means repulsion crowded. So it is difficult for OH minus to go in 3 degree as compared to 2 degree as compared to 1 degree. Because in 1 degree, there is only one CH3 and hydrogen is very small. So it can easily attack. That's why in
Yes.
back attack, 1 degree is more reactive than 2 degree than 3 degree. In 3 degree, there is 3 CH3 group, which is bulky on a single carbon. And if OH minus wants to go to that carbon, it is very difficult for OH minus to go and connect with carbon. Are you getting my point, everyone?
Yes, sir. Yes, sir.
Please write it. Please let me know when you are done with this. Nafisa, are you done with this?
No, no, sir. I'm still writing.
Okay. Also write I, Br, Cl, and F. Leaving group order. Leaving group order. So if X will leave carbon, then OH minus can come. If X will not leave X, that means halogen. So the best leaving group is iodine, bromine, chlorine, and then fluorine. Let me know when you're done with this.
Yes, sir. Finish.
Very good. So on this degree, I'm going to give you a question. In the following pairs of halogen, compounds, which would undergo SN2 to reaction faster. The first one, you have to choose one of them. The second one is like this.
Sir,
Yes.
I would have the greater sign.
Which one? This and this.
The
In the
second
first
one. No, the second one. The second question.
For SN2, I told you 1 degree is more reactive than 2 degree than 3 degree. Which one will go? 1 degree, then 2 degree. The list is 3rd degree. Can you tell me the
Yeah.
degree of halogen here? It is 1 degree and this is 2 degree, yes or no?
Yes, sir.
So this will be greater. Are you getting my point?
Yes, sir.
Tell me about this.
I will be greater.
Because both will have 1 degree, so we will go for living group. So iodine is the
Yes,
best living
sir.
group. That's why
Yes,
this
sir.
will be like this.
Yes, sir. Yes, sir. Finished. That's my answer.
Am I audible, all of you?
Yes, sir.
Yes,
Okay.
sir.
So everyone done with this?
Yes, sir.
Okay. Now going to write questions for your test. Let me know when you are done with these two questions. Then I have to write the third question. Okay.
Yes, sir. Yes, sir. Finished.
Are you done with the question number 2?
Yes, sir.
Everyone done with the question number 2? Very good. Question number 2. Okay. Now this is question number 3 then. Sneha, Nafisa,
Yes, sir.
very good. Nafisa, Fatima.
Yes, sir.
Okay, are you done with the question?
No, sir.
No. Okay, let me know when
Yes.
you are done with the question. Okay.
Yes, sir. We're done writing the question.
Okay, done writing the question, then solve this question and send, make a PDF and send it to the coaching's WhatsApp number or group. Okay.
Yes, sir.
Okay. I'll be here. Please do it.
Sir, we have to write the name for the products as well.
What you just said?
Sir, should we write the name for the products as well? Like the question number 4, the fourth
Yeah, you
exercise.
can. If you want, you can.
Okay.
Okay, thank you. After completing the test paper, please send it to the coaching's WhatsApp group and leave the meeting. Okay. Thank you.
Yes, sir.
Sir, can I leave now?